afternoon,
Yeah,
sir. Good afternoon.
sir. First of all, from Sri Vishnu Engineering College for Women, the Department of CSC, we thank you for joining with us, sir.
Thank you.
So, before I enter into the session, let me take the privilege to introduce you, sir.
Thank you.
It is my great privilege to introduce Dr. Sridhar Iyer. Dr. Sridhar Iyer received the BE degree in Electronics and Telecommunications Engineering from Mumbai University, India in 2005. He received the MS degree in Electrical and Communication Engineering from New Mexico State University, USA in 2008 and the PhD degree from Delhi University, India in 2017. He received the Young Scientists Award from DST SERB Government of India in 2013 and Young Researcher Award from Institute of Scholars in 2021. He is also the recipient of the Protsahan Award from IEEE ComSoc, Bangalore as a recognition to his contribution towards papers published, tutorials offered in recognized conferences, journals during January 2020 to September 21. He serves as a member of the editorial board of the Saihal Journal of Computer Science, Wireless and Optical Networks. Currently, he serves as an associate professor in the Department of ECE, KLE Technological University, MSS CSE, Belgavi Campus, Karnataka, India. His research focus includes semantic communications and spectrum enhancement techniques for 6G wireless networks and efficient design and resource optimizations of the flexi-grid ions enabled by STM. He has published over 90 reviewed articles in the international areas. So really, our participants are glad to have such an eminent personality as a resource person for this faculty development program, sir. Sir, now I request you to enlighten us on the topic of semantic communication for intelligent wireless networks to our participants, sir. Now the platform is yours, sir.
Thank you, sir. Thank you for the introduction. Uh, and this is my second time delivering for your department. And I thank Kiran sir for the kind invitation. So let me share my screen. Is my screen visible, sir?
Not yet, sir. Yes, sir. Now it is
Okay.
visible.
Okay, now it's visible. Okay. So I can start now, right?
Yes, sir.
Yes,
Okay.
please.
Thank you. Thank you. Okay. So again, thank you for having me and thank you for the kind invitation and the kind introduction. Well, the topic that I'm going to talk about is semantic communications for intelligent wireless networks. And I know the topic of the FTP is more related to cybersecurity and AI and ML. So once you would see this title on intelligent wireless networks, you would tend to believe that this is more on the networking and communication side. Well, that is one aspect of it. You have more of, if you want to call it, computer science related aspects in semantic communications and then intelligence. And the moment you say intelligence, you're dealing with AI and machine learning, and also there's a new concept of swarm intelligence which has come about lately. So, in my opinion, before I go into the presentation, in my opinion, there's no more computer science, EC or electrical. It's all one and the same, and we as engineers need to know all the aspects from all the departments, if you want to call it. Right. So, let me start with this. Brief retrospect on wireless communication for those of you who may not be really acquainted with wireless communication. So wireless communication basically comes about from Marconi's demonstration of wireless telegraphy, which was done in the 19th century. And like any other communication, like optical or satellite, it also depends on Shannon's theory, which he proposed in 1948. So in terms of the generations of wireless network, we've had 1G, which was basically analog, and it was basically used for voice communication. But then this was not that efficient because our applications were advancing as the years progressed, and then we moved into 2G, which is basically a digital cellular network, and that provided services such as SMS, which was basically encrypted service and data service. However, again, the applications which we have or had were advancing, and therefore we moved into 3G. So using code division, multiple access, and WiMAX and such technologies, we could get various data services enabled, and particularly internet access and video calls or mobile television. This became prominent uh, sometime around the early 21st century. Well, this is a global perspective. In terms of India, India kind of adopted all of this, I would say, around 8 to 10 years later. So around 2008, 2009, we were looking at 3G. Right? However, as the applications grew and bandwidth demand was more, we moved into 4G or LTE, more popularly known as 4G. And predominantly right now, India is more reliant on 4G networks. And so basically this applies the multiple input, multiple output antenna architecture, orthogonal frequency multiple division multiple access, the internet protocol technology, and many other technologies. And the whole aim of 4G is basically to achieve very high speed mobile transmission, which we are getting in practice in India right now. And as you all might be aware that lately our Honorable Prime Minister had just inaugurated the test bed made in India from IIT Madras on the 5G networks. So it is new right now in terms of deployment, but the research on 5G started way back in 2014. Actually, I would say 2013. And there was a lot of talk about how this network would look like. And basically, on paper, in research, uh, 5G will aim to convert Internet of Things, IoT, to Internet of Everything, which is IoE. So basically, this means we are not talking about one device being connected to another device. We are talking about every entity on this planet, in this globe, to be connected. So in terms of connectivity for humans, whether you are flying up, using an airplane, or you're, on a ship in the middle of the ocean, you're in the basement of a building, it doesn't matter where you are always going to be connected. So that is one of the aims of 5G. And so basically on paper, it is going to connect virtually everyone and everything, right? So you're going to have machine to machine communication, human to machine, device to device. It's just going to be, everything is going to be connected. So from 2020 onwards, we've been seeing the Southeast Asian countries deploying 5G, and then doing all the trials and errors on that. And now, very soon, probably this year, India will also have 5G on a large scale. So it's already time to look at the next generation of a wireless network. And I'm very happy to share that this is one of the generations of wireless network where India is taking a lead. So in earlier generations, our country was basically a follower and just tried to create those generations in India. But when it comes to the successor of 5G, which is 6G, India is taking a big lead. It already has MOU with the government of Finland, which is the leading government in terms of 6G implementation. So what is 6G and how is it different? Well, it's going to connect again everything and everyone, but it will give more capacity. So in terms of frequency spectrum, if we speak about 5G will operate somewhere in millimeter waves, which is very high gigahertz, whereas 6G would operate even higher, which in frequency terms would be known as terahertz communication. So the capacity would increase. It talks about very, very low latency. So we'll hardly able to notice any latency in communication. And it will also improve the way this large amount of spectrum can be shared amongst the users. A good news for a very populated country like India is that within a very small radius, using 6G, we'll be able to connect large number of users. Right? So the trend in wireless technology has been, as you see on your slide, here, and you can see that starting from 15 years, uh, going in from 3G to 4G, the years from the previous generation to the next generation has reduced. So it shows about 8 years or so from 5G to 6G, but in my opinion, the way the research is going, it will be even shorter. Right? So there's time now for people to sit together and start talking about 6G, which has been happening. So just to give you a little perspective, 6G research started way back in 2016. It became very prominent in 2018, and a lot of work is going on right now in 2021 and 2022. Right? So what is the catch behind this 6G wireless networks, right? So a lot of applications such as holograms, holographic communication, virtual reality. In fact, I should say it won't be AR and VR. It will be a mixed reality, which will be one of the use cases of 6G. And then all this virtual connectivity of the globe. So those are the use cases of 6G, and this cannot be supported with lesser frequency, say about 30 to 100 gigahertz, which millimeter waves in 5G is going to provide. So just to give you a perspective, if we compare 5G to 6G, you can see at the top there the user experience data rate, and this is what the customer is looking at. So if I have 5G network, it will give me around zero point 0.1 Gbps, whereas there'll be a 10-fold increase in 6G. So I'm going to experience about 1 Gbps, right? So that's a 10-fold increase. So I'm really looking forward to a network of 6G. In terms of spectral efficiency, there'll be a 2-time increase. As I was saying before, the connection density, you can pack in a lot of users in a very small radius. So it works very well for a very populated country like India, right? So in doing all these use cases, this kind of spectrum, which is supported by millimeter waves and 5G, may not be enough, and researchers have identified that, right? So in terms of 6G, you're looking at more capacity, and therefore you will get more coverage. So you'll be able to cover the terrestrial region, the region in the sky, in the ocean, and so on, and you'll be able to connect everything, right? What we basically infer is this: as we move ahead in generations, going from 3G to 4 to 5G to 6G, the only thing that we've been thinking about is to increase the frequency, right? So that's the inference that we get. So I'm talking about 5G being at millimeter wave, and since the applications are advancing and the computational complexity also increases, I need to give higher bandwidth to 6G. Therefore, I'll just notch up the spectrum a little bit, right? So I move from millimeter wave towards terahertz system, right? So what are the issues out there, right? And this brings us to the motivation of what is semantic communication, right? So the whole idea here is, if we want to move from a lower spectrum, let's say millimeter wave, to terahertz, higher spectrum, because I want to only reproduce what has been sent. So to give you an example, if I say over the phone, hello, how are you? My intention of communication is only to send this hello, how are you, as it is at the receiver. So more the message that I have, more the bandwidth is required, and more the frequency spectrum I will require. Right? So that has been the basis of the communication which has been proposed by Shannon. And this kind of a communication where we reproduce what has been transmitted as it is known as a level 1 communication, which is also in other words known as a technical problem, which was proposed by Shannon. Right? Of course, this kind of a problem and solutions to this kind of a problem has led to a lot of advancements. So as I was mentioning, we have multiple input, multiple output, which is a very hot topic of research these days. You have intelligent reconfigurable surfaces, which are an advancement to antenna techniques, which are being researched a lot. You have software defined networking where a human intervention is not at all required. The network only learns from the environment, let's say using some kind of reinforcement learning, probably forms a Q table, learns, the better the state, the better the action, gets more rewards, and then adjusts all of its capabilities, right? So this kind of advancements have happened once we have tried to find the solutions to the level 1 problem. But there is a problem here. As we move up in frequency, the very first thing that comes to mind in a lot of people's mind is the radiation effects, of course. But there is a catch to that. I'll leave that because that is not the scope of this presentation. But uh, aside from those radiation effects, you also have atmospheric blockings, in the sense when you send the messages and the signal, the higher the frequency, all your signal, electromagnetic signals which we are sending, they get absorbed and they get scattered. There's going to be propagation loss. So the line of sight or the distance of communication is very, very small. And of course, we are communicating to have as large distance of communication as possible. But as we move higher up in frequency, we see that the line of sight is actually lower, right? So in terahertz communication, for example, till now we have only seen good efficiency in indoor communication. So probably in an office environment. But we all are aware that that is not going to suffice our purpose, because I need to transmit, let's say, sitting here probably in Mumbai, transmitting all the way to the United States, right? So that's a long distance transmission. So going up in frequency, yes, it serves the purpose in terms of spectrum, but it also creates a lot of bottlenecks in terms of resources. For example, spectrum is one, and the other is the more you need to send the data, the more the energy and the power that is going to be spent on it, right? So what is the other solution that we could have regarding this, right? So the other solution is thinking from a machine learning or an AI perspective. So if you think about it, if you want to transmit data which has been transmitted by a transmitter, and if you want to reproduce that data as it is at the receiver, then I'm talking about inductive learning, right? What I've induced is whatever I see at the transmitter, I just reproduce that at the receiver. The meaning of this data is not taken care of, right? Whereas if you think about AI machine learning, which basically comes, arises from the human mind, and our human mind is basically dependent on experience, which we also call as deductive learning. So in that case, if I say hello, how are you, and at the receiver I only listen to hello, pretty much I can say that the next three words will be how are you, because over the years I've experienced that I start my conversation on a phone saying hello, how are you, right? So what does this do? What it does is I don't have to now receive how are you in terms of the data, because I've already identified from hello that the next data is how are you, right? So with this concept and logic, I'm able to save the resources, right? So I don't have to really spend a lot of bandwidth and a lot of power in terms of receiving all this data. So that's the whole idea of what is known as the semantic communication, where semantic basically means the context of the data which you are transmitting. So makes sense. I can transmit the data as much as I want, but I receive only what is meaningful for me. And if I'm able to interpret from that meaning the transmitted data, I'm able to save a lot of resources. And this can do wonders to various networks. And this is what me and my group are trying to do for wireless networks, because wireless networks just blindly moves into higher spectrum like terahertz just because it wants to reproduce the data which has been transmitted. Right. So the whole idea is about saving the resources and using those resources elsewhere, so that the efficiency of the network really improves. Okay. So what is the alternate solution? Well, funnily enough, this alternate solution was also given by Shannon in his theory in 1948, but no one really paid attention to that. The researchers at that time and henceforth only paid attention to the level 1 problem, which is to reproduce the data as it is. But Shannon also identified a level 2 and a level 3 problem, and which now in the current age, specifically after the pandemic era, has become really important to us, in the sense that the level 2 problem identifies semantics or the context, and level 3 identifies effectiveness of the system, which is really important, especially for us, the faculty members, because we've been teaching online for a lot of time. And let's be honest about it, it has not been really effective because we've not done it with some kind of effectiveness. So this kind of semantic communication has a use case in online teaching and learning, which is also known as online pedagogy. and a lot of research is going on, right? So what is this level 2 and 3? So as I was mentioning, level 2 aims at the semantic, which is also meaning or context of the transmitted data, and level 3 really focuses on how effective this exchange has happened. So as I was mentioning, taking the example of online learning, well, we always taught online, but really we never took a feedback from the students or the learners and how effective it was, right? Where semantic communications will do that for us, right? It will really identify whether this effective exchange of information, intended information, has actually happened between the transmitter and the receiver. So later on, sometime I will show you. I have a slide on that where online learning, teaching and learning is also a use case for semantic communication. And of course, the backbone of all that will be some kind of network. So 6G network will provide all the bandwidth. Okay. So earlier generations just operated on the under the umbrella of level 1. They never bothered about level 2 and level 3. Well, with 6G, semantic communication becomes very important. So our perspective, and by our I mean there are a few more researchers around the globe who are working on this. So our perspective is basically not just focus on how to transmit. Well, that is important, but we also aim to see what to transmit. So we are very particular about what data has been transmitted, and if there are redundancy in the data and all that, that can be gotten rid of using semantic communications, and you save a lot of resources, right? So what is basically the aim of semantic communications? Well, first is to adopt level 2 and level 3 in the design, deviate from the current communication, which is only to reproduce the data. It will involve what is known as knowledge sharing, and this knowledge sharing hub has to be created using machine learning and AI techniques. In my research till now, it will basically involve deep reinforcement learning, DRL techniques, but you could also have better techniques, and we still are researching on that. The other aspect that semantic communication will provide is to serve in the interaction of human to machine and machine to machine communication, which is also one of the use cases of 6G. It will also intertwine multiple natural and AI techniques. Right now, many natural techniques, for example, if you take techniques from graph theory, let's say a branch and bound technique, which is an older technique, and if you take any AI technique, let's say some kind of Q table technique, these are standalones. You do not merge them. We see them as natural technique and we see them as AI technique. But what if you are able to put them together and you get better techniques? So semantic communication will also help us in identifying those kind of techniques. So the result, what we envision is we are able to get the meaning of the data, and from that we are able to get the data. We accomplish a goal, and then whatever the transmitter has transmitted, I am also able to receive the same thing, which is basically the goal of communication. So if all of this is solved, then semantic communication does a much better job than the actual communication which is happening right now. Right? So these will be some of the advantages, and I will focus a little bit more in the upcoming slides. So the first is I really focus on only the information which is absolutely required. Anything else, I'm really not worried about it. AI and ML techniques will build what are known as learning strategies. Till now, we don't use AI and ML as a learning technique. We are using them more to automate the system, but I want to use AI and ML more as a learning technique. It will definitely improve the performance, and it will lead to what a new kind of communication which has come about in the last 6 months or so, which is known as goal-oriented communication. So I already prefix a goal, and I only work towards communicating towards that goal. So that is known as a goal-oriented communication, right? So overall, by not considering the irrelevant data, it will significantly reduce the bandwidth, latency, and the energy demands. And this is from a networking perspective, right? So the inference is you get a goal-oriented communication through semantic communication, and this is an open area of research. If for those of us who are more into education technology and who want to improve the education delivery, this goal-oriented communication will play a huge part. And you have many service providers of education who are working rigorously on this, because ahead we are only going to have online education. Of course, offline will work in India for a long time, but still a lot of it has become online, so it needs to be effective, right? And the other aspect that it will bring about is how to have an error-free communication at the level 2, the semantic, and the level 3, the effectiveness layer, because the same is being done for level 1, which is the technical error. Right? So this is the architecture, a proposed architecture of semantic communication, and we put forth this in one of our latest survey article. I'll give you a reference of that in the last slide. And so what we envision here basically is that you have the TCP/IP or the OSI layer. Well, I would say only the TCP/IP layer, which is the technical layer that you see at the bottom, and you have various networks resources. So you have the bandwidth which is available, the power which is available, and you have various applications. Let's say, for example, cloud computing, and all of this is basically dependent on the raw data or is giving out raw data, right? So from all of this, which we are already used to, now we create a base of knowledge. So we create this knowledge. So if we take humans, for example, if I'm a, let's say when I was a baby, I really was not used to the winters. So I didn't know what would happen when winters would come in. But as I grew, let's say a 5-year-old, I came to know that, yeah, winter, I need to wear sweaters. Once I was 10-year-old, I came to know that, okay, not the sweater is not enough. Probably I would need gloves and other kind of things. So as the years progress, my base of knowledge is also increasing. I have more inputs over the years. So a same kind of technique can be used at the semantic layer, which is the level 2. And then here you would have what is known as an AI logic cloud, which is obviously virtual, but it would provide all the logic towards this base of knowledge. And then you have the various semantic services. For example, cloud computing could be one of the services which can also be catered to by the level 2, right? But what we'll have at the level 2 is the inference and how to represent this knowledge, right? Because the same thing, the same knowledge could be required for any other use case, right? So I have a similar knowledge of winter, the example which I was using, could be required for when it is not acutely winter but slight winter, and where I do not need gloves but I still need a sweater. So I would use the same knowledge which I have accumulated in my brain in this base of knowledge and use the same thing. So there's no point in repeating this knowledge again and again, right? And to ensure that these two levels, the technical and the semantic layer, work really well together and work and focus towards a particular goal, the effective layer comes into the picture, where you could be dealing with edge computing, which is again a hot topic of research, cyberspace, because all of this is not possible offline, it has to be done over the cyber. And then you have what is known as the application space, where the user would actually sit in front of the machine, let's say a laptop or a tablet, and is actually accessing all these, right? So here you would need a lot of control optimization and actuation. So this kind of control and the optimization required here would be absolutely different to the one which is used at the technical layer or the level 1 layer, right? So a lot of activities can be done and a lot of manipulation can be done in these kind of levels. But this is just one of the first proposals that we came up with, right? So in all of this, being computer scientists, we would be aware that this will require a lot of cross-layer interaction, because level 3 should interact with level 1 and level 2 and so on and so forth. So therefore, an effective cross-layer interaction is required, and that's an open area of research. So you can take communication, semantic communication, and see how an effective cross-layer interaction can be had between these layers. Right? The other aspect would be that if all of this works well, it still needs to be seen over a period of time, then we would get significant improvement in the network performance. As I was saying, level 3 will also help us in achieving a specific goal. So right now in communication, the only goal is to reproduce the same data, but there are also other specific goals which we can have with semantic communication. So I'll let you know what are the major use cases from semantic communication. Right. So how will this model look like? Well, it will deviate from the level 1 aspect. So instead of the probability of occurrence of data, which we use in communication today, it would rather be the content and the meaning that will have more value. The exact content of the data will be more important rather than the data itself, and the knowledge level which is available for with the transmitter and the receiver will be very, very important. So AI and ML techniques, which are still being researched, will really help in bringing this transmitter and receiver in sync so that the knowledge level and the base can actually increase. Right? So this representation of knowledge, which is base of AI mechanism, this is under research. So someone who gets a spark of research listening to semantic communications can really look at what are the AI mechanisms which can be used to represent this knowledge and how to create this knowledge, right? So in communication and many other areas, we are creating a lot of knowledge, but we are not using that knowledge effectively. So if we use all of this knowledge effectively, we'll be able to train the system or the network or the device much better. And you know that once you're able to train it better, then the automation of that device or that system happens much better. Right? So a base of knowledge representation and interpretation will be required, and this is one of the areas that we are working on. So this knowledge, base of knowledge will have incomplete description because you are not transmitting the data as it is, but you are only transmitting the context or the meaning, and from that the data has to be retrieved. Therefore, this will be a key feature, the incomplete description. And but this will require a large amount of time because you are from this incomplete data you are actually finding the meaning of the data, right? So the computational complexity is also going to increase, so we need simulators like that. We know we need AI hardware, ML hardware, which will work like that. So that's something to be researched on. uh, the received data will depend only on semantics rather than what is known as syntactics. Syntactics is the actual data. So there's a lot of research now going on as syntactics versus semantics, and you know which one is more value than the other, right? So that's an open problem of research. So this is I just want to give you a glimpse of one of our proposals on how to do the coding, the source and the channel coding. I can understand if many of the participants are not into the communication domain, but this is one of the proposals we gave on how the level 1, level 2, and the level 3 would look like once you put a microscope into it. So once you zoom in, you will see that at the level 1 will be the usual transmitter and receiver, where you have an encoder, you have a channel, let's say Wi-Fi for example, you have the noise, the same noise which is going to affect the data, and then you have a decoder, and you are hoping that the received data will be same as the source data. Okay? And then you come to level 2, where you have semantic encoder, where we really don't know what the semantic encoder would look like right now, but pretty much it will be an advanced version of a compressor. So you would have to use many compression techniques here, right? So you're taking a large amount of data by the source data, and you only extract the meaning out of it. So you're filtering it. So this encoder is basically a compressor, right? And then you have a channel, which is a semantic channel, and then you have noise, which is semantic noise. Now this noise is going to be different than the actual noise, which affects the amplitude of the signal. This noise will be basically when I'm not able to understand the meaning of the data. That will be the noise there. And then you have the semantic decoder, and all of this will be dependent on the base of knowledge. So if my base of knowledge is good, as we say in layman terms, if your brain is having a lot of information, you'll be able to function well. So if my base of knowledge is really good, then the semantic encoder and decoder works well, right? So again, my hope will be that the received data is much better. And then sitting at the top is your level 3, which will basically be monitoring the levels at the bottom and see whether a particular goal has been met or not. And that will have an encoder and decoder itself. So it gets as the input the data summary, and then it just sees how the receiver is conducting. So if I take the example of online teaching learning, if I really get a good feedback from the learner that how effective the sessions were, then the teacher or the instructor at the other end will try and improve his delivery, and this cycle should go on and on. Okay, so this is what works here. And as I was saying, deep reinforcement learning right now has been identified as one of the best techniques to work with it. And of course, DRL works with agents. These agents work with the state and the environment, based on which they take certain actions, and then based on their actions they are rewarded. And obviously we choose the best rewarded agent, and that agent keeps reperforming again and again. So as of now, it looks like reinforcement learning is one of the techniques, but better techniques could turn out as the research goes on. Right? So I've already explained you what the semantic encoder would do, and that is what is there on the slide. So I will share the slide with Kiran sir, and then you can probably sir can give it to all of you. But basically, the whole idea is that the encoder and decoder should work in tandem, and it's basically a compressor which is going to take all the data that we have and filter out the meaning of that data, and then through the channel it will send it to the decoder, and the decoder's aim will be to understand all this, the meaning of this data, and then the effectiveness layer will see whether the receiver has really understood this or not. Okay? So what are the errors in syntactic and semantic communication? This is something which I mentioned as well. The error at the syntactic layer, at the level 1 layer, is the actual noise, which is going to affect the amplitude or the volume of the signal. Well, that is not going to be the case at the semantic layer. At the semantic layer, the error basically is going to occur because I'm not able to interpret the data correctly. So these are two different kinds of errors. And even with a few errors, the interpreter at the semantic level can still recover the data. Right? But if I'm not really understood the meaning of the data, then without noise also, I'll be making a lot of errors. So there's a lot of activity to be done at the level 2. It's not the same as level 1. For level 1, most of the details are already available because this kind of communication has been happening for the last 5 to 6 decades, right? But level 2 is something new which has come about. Okay. So this, I hope that I'm able to give some glimpse into what we are trying to do, in the semantic communication for wireless networks. So again, I just wanted to give you a glimpse of what are the use cases of semantic communication. So you have holographic communication, and this is something which we'll see very soon in probably a couple of years or 3 years. Audio and speech communication, semantics is used a lot. Video communication, intelligent communication, which we are using. And as I was mentioning, goal-oriented communication, online learning, and then you have something which is machine learning for wireless networks. I'm not going to take all the use cases. I just wanted to give you a glimpse of what me and my research group is trying to do here. So there are a couple of use cases which we are focusing on. The one is obviously machine learning for wireless networks. So what we have really identified is that the current machine learning algorithms and techniques really do not provide good privacy and security in wireless networks. So we are working rigorously towards how to formulate newer machine learning techniques. The reason for that is the current machine learning techniques used for networks are basically inductive. They're not deductive. But once you are looking at an advanced version of use case, you need deductive kind of machine learning. So we are tweaking the existing machine learning technologies to see if we can have some deduction out of those machine learning techniques, right? So basically what we are believing is to incorporate knowledge from external world and then including this in the decision making process. So we want to have the natural processes which are available and the machine learning techniques which are available, and we want to mix them and see what kind of a technique really comes about, because currently they both are standalone. When we talk about AI and ML techniques, we are not talking about the other natural processes, but in our opinion that should not be done, right? So basically we believe that newer ML techniques will be required. This will be used for representation, for reasoning, for more logic to enhance the base of knowledge, and through that we'll be able to optimize the network and any other use case much better. Right? So what we have identified till now, I'm saying till now because in further research probably we identify something new, that the transfer learning machine learning technique shows real good promise. So if you are able to use that kind of a technique for optimizing the wireless network, it will be much better. So this is an open area of research, and we have a lot of computer scientists working with us because they have really good knowledge of transfer learning, and in our group we have good knowledge of wireless networks. So we come together and work and see whether this transfer learning is really good to have a base of knowledge, and then can this knowledge be transferred and shared so that the resources can be saved. So as I was mentioning at the beginning, we can't be standalone engineers like computer scientists or communication engineer. They all need to come together and work on these kind of problems. The other area which we are rigorously working on is what is known as goal-oriented communication. So what we really believe is that there's a lot of opportunity in goal-oriented communication. We want to optimize the performance of the network, also of the algorithm, the AI or the machine learning algorithm we use. So we want to decide the goal of this communication. Right? We don't want the network and the AI algorithm to not know the goal. We don't want to use AI just to automate the system. That's not our goal. Our goal is to actually optimize or improve the performance of the network. That's our goal. So we want an AI or machine learning algorithm to do that. And in this process, it will automate our system. But automating the system is not the goal of AI. So like this goal-oriented communication will be a new form of communication is what we believe, through which we are able to meet certain specific goals of communication, right? So existing work, what we identified is it basically misunderstands the communication parties, which is the transmitter and the receiver, and there's no protocol agreement between the transmitter and the receiver. It is assumed that both use TCP/IP, for example, but what really is happening between them virtually is something which we are not able to identify, and goal oriented communication will actually do that. So basically what we are looking at is to fulfill a goal, so that the system performance would really improve and then complete this specific goal, right? So effectiveness, the level 3 will be one of the things that we would look at in this context. The other is online learning. I think I've spoken a bit about online learning, and I think all of us can relate to it because we are from the faculty, fraternity. So 6G will contribute a lot. In fact, 5G is contributing a lot to online learning, and this will remain with us. So in this, basically, we want to ensure that ML, the machine learning algorithms, are implemented for various activities for online learning. For example, communication, also computation. Like if you take attendance, for example, that's a computation burden. So that is in the advanced online learning, we'll be able to do that. How to control. So for example, if someone is muted or not muted, can we really automate that kind of a system? What infrastructure would we have if certain platform of online teaching learning is taking a lot of RAM speed? Can we improve on it? So those kind of things can be done with online learning. So semantic communication will really come into the picture there. So what we really want to do here, and there are also researchers abroad who are actually doing, is again to move from inductive machine learning towards a deductive machine learning and use the context and the semantics. And there's a lot of research going on. So if anyone is really interested in this education learning perspective, then this is something to really look at. Right? The next is this is directly adopted from a recent survey article. So we have existing challenges and proposed directions. Well, I'm not going into the detail of this because each of the existing challenge is a use case by itself. For example, holographic communication, XR is for mixed reality. You have sense communications. The sampling. If anyone is interested in the mathematical aspect, performance metrics. You have semantic networking. You also have scheduling and resource allocation. So that's more of a computer science problem where you use protocols to schedule, how the access of the network is going to be done. You have knowledge modeling. This kind of modeling has come about very recently, where we have all the knowledge, all the material, but you're not able to model it. Right? And then what will be the flow control? How the information is going to flow from which layer to which layer, which block to which layer. So there's a lot of existing challenges. There are a lot of proposed directions which we have given. There are other researchers who have also given the proposed directions. So I'll share the slides, and then you can have a look at it, and you can pick one of the use cases which is interesting to you. So overall, to conclude, well, we believe that semantic communication will really work towards the sustainability of wireless networks. That is the main aim, and it will be able to, save a lot of resources. Basically, in networking, we are interested in two resources. One is spectrum, and the other is energy. and we call it spectrum efficiency and energy efficiency. So that will be able to reduce, that we can reduce using semantic communication, and we'll be able to also utilize, some untapped capabilities in terms of computation, infrastructure, AI, and machine learning. So this will basically be a newer kind of technique, but much research is required. There's a big group in the United States working on the distributed computing techniques in semantic communication. How to also exploit this already existing knowledge which I was talking about. And we are in my group we are working more on the goal oriented communication, and of course the mathematical aspects as well, into source coding and channel coding. So overall, we believe that semantic communication is there to stay, and it will make the network much better. It will move from inductive towards deductive learning. So these are some of the references. Reference 2 is one of our recent survey article. You can have a look at it. It's there on ARXIV as a preprint, and it's under review. You can also subscribe to my YouTube channel, wherein I've put a lot of videos on 6G networks, and I also put a lot of videos on the basic research on how to write an article or write a proposal and so on and so forth. So I hope with this presentation, I've been able to give you a glimpse of what this semantic communication is. Well, I have only given a perspective from wireless networks, but this is being used a lot. If you see, if you just go over a search engine, you can see that this has been used rigorously for speech communication, audio communication. So there's a lot of scope for semantic communication, and requires very advanced AI and machine learning algorithms. So that's all from my side. If there are any questions, I'll be happy to take it. Thank you.
Sunil sir, if the participants can interact with the resource person, they can please.
Yes, sir. Yeah, dear participants, if at all you have any queries, please unmute yourself and you can ask Iyer sir. Sir is ready to answer all your questions. You can unmute yourself and ask the question.
Participants can also contact me over email. We are always ready to collaborate over research. So my domain basically is wireless networks and also optical networks, and I work a lot with the machine learning aspects in how to automate the system. So you can feel free to contact me at all times.
Good evening, sir.
Good evening.
This is Jyoti. This is Jyoti from Hyderabad, St. Francis College. First of all, thank you to Sri Vishnu Engineering College for Men Bhimaram for providing such a wonderful opportunity and giving me the opportunity to join the FDP. And the topics, whatever you have chosen, or I really appreciate kind of things which are really required in this current generation, especially for the faculty, because for the students, we need to cater for various streams, right? So this is what the knowledge is required for the faculty. And I have a question for you, sir. Shashidhar sir, thank you for your wonderful, explanation, and the people is really, I'm impressed because the explanation of the semantic communication and how exactly we are going to use this in the online, because everyone know that online education is something like e-learning or digital learning, but there is a lot and lot as we dig. It's an ocean what exactly we have to go through. So actually my research paper is related to something to that. It's not a semantic communication, but it's related to the new emerging technologies basically, where I want to look into the thing of cyber security, how exactly that will enhance in order to using the ICT, etc. So definitely I'll contact you, sir, for further many queries I have right now. I cannot ask, but one thing is, as you said in the tree where you have showed that formal kind of the thing and mundane kind of thing, or scientific kind of the ways we have, right? The different ways of the research. So in that various research, if we are going with the protocols of communication, semantic, and definitely we require the reinforcement because the decision should be taken instantly based on the situations, right? So how exactly we need to implement that? How exactly? Because right now in this current generation, in this scenario, implementation is not that easy because we need to test a lot and it is taking time. So how exactly we can go for that reinforcement? Because unless and until we do that, we cannot come to the conclusion, right? Based on, if you want a feedback or if you want something, we require the original data. That original data comes when you are giving directly. But when we are using this technology and if you want to go for this reinforcement, how exactly we can do that? And where it lands, whether under which category it lands, if we are going with the semantic, whether under the first category or second category, mundane, and the third category formal.
Okay. So thank you for your question, ma'am. I would answer this saying that you have actually not asked a question, you have put forth a research question. So, how is reinforcement learning going to work? Well, that's exactly something which we are learning about. Because if you see, basically RL will use a Q table because we
Yes,
know
sir.
that Q table has a better computation compared to other
Mm.
existing techniques. So you are always inclined towards using reinforcement learning, and then you advance it to say deep reinforcement learning. Well, how will it really work? Well, you can see one of the disadvantages already because you need to make a Q table. Now, if you're going
Yes.
to have 1,000 students in your online learning class, and for each session, if you start making that Q table, it's not going to be, it's not going to be efficient. So
Yeah.
that's a research question. If I have to use RL, which is one of the good techniques, ML techniques, which is existing, but then for this particular use case, it becomes an issue if because I have large number of learners. If I take your education into the perspective, so that's something to be researched upon. So but now where will it land? Well, I would say, in my opinion, as of now, with what I have read, it would land into the level 3, which is more of a user accessing this whole method, which is the effectiveness layer, which we also call as the application layer in OSI or TCP/IP, right? So the user is only going to look at the answers, but he's not going to
Yeah.
be looking at how you are actually getting these answers. So it will be more, to answer your query, it will be more like a formal way in where we end at. But then again, I could be wrong because in a couple of years or so, we could really look at advancements in semantic communications.
Yeah, maybe it's a hybrid where we have to learn, we have to take a new role.
Yeah,
Thank you, sir.
so
Thank you for
that,
answering.
Sunil sir, we can proceed, it seems.
Yes. Yeah. Thank you so much, sir. Yes, sir. Despite of your busy schedule, you spent your time more than what we expected time, because we expected half an hour to 45 minutes, but you took around 1 hour, sir. But really, it is very much interesting because you started from the basics of this semantic communications in intelligent wireless networks, sir. Because it mainly focused on you started with retrospect and what may be the trends in the upcoming 2028, how will be the trend is going to be become, and you mentioned how it is transforming from 5G to 6G, and what are the motivations to move from semantic communications. There we focused with the aim and advantages of this semantic communication, and you explain this with an architectural diagram also, with a neat level 1, level 2, and level 3, in each level what it's happened. So everything you clearly explained, sir. And you also mentioned the source and the channel coding also, because ma'am also asked some questions related how to implement this. So you gave an extraordinary response for them, sir. Really, our participants are very glad to have such an eminent personality in this faculty development program as a resource person. Really, from the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram, we convey our heartful thanks to you, sir, for sharing your knowledge with our participants. In the beginning itself, you mentioned this is the second time you are giving the lecture in our association. We hope this association will continue for a long,
Sure.
sir.
Sure. It will. Anytime. I'm there anytime.
Yes,
So
sir.
as soon as Kiran sir mentioned, I just said yes because it's a good platform to share, whatever I read, and hopefully, it just gives us spark. So thank you so much for having me. Thank you, Kiran sir.
Thank you. Thank you, sir.
Definitely will be. Yeah, definitely will. I'm always there whenever you conduct such kind of, FDPs or STCs.
Actually, it's our privilege to see you online, actually.
So,
And hope we have this association in future endeavors also. We'll do that, sir.
sure,
Thank you.
sure. Thank you for having me. Thank you.
Thank you, sir.
Thank you. Okay, so I'll take your leave. Thank you.